or the change in length of carbon chain. Either you can change the length of the carbon chain or change of the functional group. Okay, you have different types of organic compounds in your igcse 0620. You know that you have the alkanes, then alkenes, then alcohols, carboxylic acid, esters, and halogenolkenes. Generally, the alkanes, they can be represented by a general formula CnH2n plus 2. This is the ratio of the carbon and hydrogen. So the hydrogen must be 2n plus 2. If you have 4 carbon atom, make it double, add 2 more, you will get the ratio of carbon and hydrogen. So if it is C4, and then hydrogen must be 8 plus 2, 10. Now you can use the same idea for the general formula of alkane. So for the general formula of alcohol, CnH2n plus 2, if you add one more oxygen, you will get the general formula of alcohol. Alkene, CnH2n. This is the general formula of alkene. To get the general formula of both carboxylic acid and ester, use the general formula of alkene, CnH2n, and add two more oxygen, CnH2nO2. Then for halogenoalkane, halogens, you know that the halogens are the group 7 elements. It may be fluorine, chlorine, bromine, iodine. Okay, for the general formula of halogenoalkane, if you have a halogen like that, if you have a chlorine, you can attach here, you can write like CnH2n plus 1. Now, this is chlorine. You may attach fluorine, bromine, or iodine instead of chlorine as well. Okay, so this is actually the information about some types of the organic compounds, along with their general formulas. Now, I have already discussed the isomers of alkane. Let me discuss about the alkenes, alcohol, carboxylic acid, and ester. Keep in your mind that if you want to draw the isomers, what should be done? Change the length of carbon chain or position of functional group. You will get another form of isomer. Now, now the next thing is that if I want to draw the isomers of alkene, alcohol, carboxylic acid, and ester or halogenoalkane, we can use both the things. I mean, we can change the position of functional group in the position of double bond, the position of halogen, the position of OH, and we can also change the length of the carbon chain as well. So let's start from alkene. If I have a structure like this, mm, the four carbon atoms are bonded together. So let me draw a double bond here, uh, here. Okay. Now, if I change the position of the double bond, I may get the structure like that. Now, this is the double bond between first and second carbon, and this is the between second and third carbon atom. Now, I can draw another structure in which if I keep the double bond at the same position between first and second carbon atom, but if I draw and if I change the length of the carbon chain by making the fourth carbon atom here. Now, let me complete the uh, structure of alkene by putting hydrogen. You know, this carbon is bonded with two carbons, so just add two more hydrogen. This carbon is with three. Okay, so just add one hydrogen atom, two bonds with this carbon, just add two hydrogen atom, one bond with this, add three hydrogen. So this is the complete structure of first isomer of butene. Now, one bond is there, you can add three hydrogen. So three bonds are already there. So add one hydrogen, three bonds are already there, one hydrogen, one bond is there, add three hydrogen. Here you can add three hydrogen, no hydrogen, because this carbon is bonded with four other carbon atoms. So add two hydrogen. If you look at the molecular formula of all these three structure, you will find that they all contain four carbon atom. And let's look at the hydrogen atom, 3, 5, 6, 7, 8. Okay. So C4H8 is the molecular formula of all these three organic compounds. But as you can see that they have the different structural formula in the terms of position of double bond. So this is the double bond between first and second carbon atom. And here between second and third carbon atom. Here between first and second carbon atom. But actually the length of the carbon chain is different. So if you look at the longest chain contains four carbon atom. It means this is but. But just mention the position of the double bond as well. So the double bond starts from the first carbon, so that's why this is but1ene. Now, the same length of the carbon chain, this is again but, but the double bond starts from the second carbon, so this is but2ene. Now, the longest chain contains three carbon atom, and the double bond is on the first carbon atom, so we can say prop1ene, or we can say the propene. Now, the second carbon contains CH3, which is as a substituent or branch. So this is 2-methyl. So the complete name of this alkene is 2-methyl prop1ene or 2-methyl propene. And this is butene. So butene has three possible structures. If I say that this is A, this is B, and this is C. So in A and B, I have changed the length of the carbon chain, but the position of the double bond is same. But in A and B, I have changed the position of the double bond because the double bond is on second carbon. But if we compare the B and C, I have changed the position as well as the length of carbon chain. So this is the important point, that if you change either the position of the functional group, double bond is also a functional group, or if you change the length of the carbon chain, you will find another structure or another isomer of that molecule. Now let's talk about the halogenoalkane. Now, you know that the halogenoalkane, they contain either chlorine, bromine, or iodine. So that can be done in the same way which you have done for the alkene. If I say that I have four carbon atom and chlorine is here, if I change the position of the chlorine, like if I put the chlorine here, okay, let me draw the different possible structure. If I put chlorine here, okay, now this is, and if I put chlorine here, or if there are four carbon atom, three carbon atom, if I put chlorine here, okay, and then fourth carbon atom here. Now look at the first structure. This is CH3, this is CH2, and CH2, CH2Cl. This is CH3, then CH2, CH3. This carbon is bonded with three other atoms, like two with carbon and one with chlorine. So to make it tetravalent, just add one hydrogen. Okay, this is CH3, this is CH3, CH2, bonded with 3, one more hydrogen, then CH2, 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 CH3. This is okay, CH3, this is CH3, this is CH3. Now look at the different possibilities. You may draw some more structures as well, but look at these possible structures. Now, just look at the longest chain. This is the longest chain which contains 4 carbon atom and the chlorine is on first carbon. Start numbering from either side. Prefer the number which is prefer the least number. If you start counting from this side 1, 2, 3, 4, this it may be 4 chloro. From the right hand side it is 1 chloro. So this compound is 1 chlorobutane. Okay, so this is actually 1 chlorobutane. Just think about the second. 1, 2. Okay, now chlorine is on second carbon, so this is 2 chlorobutane. Okay, now just think about the third one. If I start numbering from this side, 1, 2, 3, or from this side, 1, 2, again, this is 2 chlorobutane. So these two structures are same. Either you can draw this one or this one. Now, look at this one. If I start numbering from this side, 1, 2, 3, 4, the chlorine is on fourth carbon. And if I start numbering from this side, this is 1 chloro. These two structures are same. Okay, and these two structures are same. Now, this is the propane. This is the longest chain, which contains 3 carbon atom. But look at the second carbon atom. Second carbon atom contains 2 branches. Number 1, chloro. Number 2, methyl, CH3. So this is 2 chloro, 2 methyl propane. Okay, you can make some other structures as well. That if I say that there are 3 carbon atoms here, so the first carbon contains chlorine, and if you make a branch here, CH3, this is CH3, this is CH, this is CH2. Now this is the first carbon, and this is the second carbon, this is the third carbon. So it is 2-methyl or 1-chloropropane or 1-chloro-2-methyl propane. This is 1-chloro-2-methyl propane. Okay, so I have changed either the length of the carbon chain or position of the functional group. And this was actually regarding halogenoalkanes. So I have drawn the different structures of what the name of this organic compound was. There are 4 carbon atoms. And then look at the hydrogen atom, 3, 5, 6, 7, 8, 9. 9 hydrogen atom and Cl. So this is actually C4H9Cl, and these are the different isomers of chlorobutane because the general name is chlorobutane. So chlorobutane has different types of isomer, 1 chlorobutane, 2 chlorobutane. Okay, it may be 2 chloro 2 methyl propane or 1 chloro 2 methyl propane. Now, the next is uh, carboxylic acid